The last assignment has to do with what happens when you go from when you have a wave that is hitting a fixed point or a loose or free end. And I want you to picture it this way. You have a rope like this, and you're standing over here, and then you move that rope up and down, and so a wave goes down here to this point. But think of this as a fixed point. So that rope is tied to maybe a stake here in the ground. So think of it this way. If the wave is above like this, when it hits here, okay, this is what we call a fixed end. This is a loose end, okay? So this wave will move along here, and when it gets here, this ring, let's say, is going to be able to slide up, and then it's going to be able to slide down. This one's fixed. This one will be able to slide up and then slide back down. Now think about that in terms of a fixed end and a loose or free end. Then we're going to come back to the first page. I think it's easier. I think it'll make more sense. So if you have a wave that's moving this way and it gets reflected from a fixed end, okay, that's going to get flipped upside down. We say that it is inverted. But if it's from a loose or free end, then if the wave was above like this, when it meets that ring is going to go up, and then it's going to come back down, and that wave does not get inverted. Now here you have a different shape wave from a fixed end here. You can see how it gets flipped upside down. From a loose end, it goes like, it looks like this, going to the right, and then it's coming to the left. And all of these are just different shaped waves, and they're getting inverted here, but they are not getting inverted there. Okay? Now, let's look at the bottom here. I made a little diagram, and I covered it up before. I want you to think that if you go from, say, a light rope, all right, so low density to high density, think of it as a fixed point here. If you're going from heavy to light, think of that as a loose end, okay? So if you're going from light to heavy, then this is going to seem like a fixed point here, tied at this end. But if it's heavy to a lighter, or from heavy, more dense to less dense, this would be less dense to more dense, then think of it as these two situations. Okay, now let's go to this to the first page. You got some vocabulary words that you got to keep track of. Incident means what you're starting with. Okay, so this is the incident wave like this. The reflected one, okay, is what's going to be going back in this direction. The one that's transmitted is the one that comes out of this medium and goes into this medium. All right. Now you have a fixed end and the loose end, which we talked about before. So let's think about it this way now. A reflected pulse in medium 1, if you're going from more to less, that's like the loose or free end. So it will not be inverted. Okay. Now the speed of the reflected pulse is going to be the same as the speed of the incident pulse. So the reflected pulse coming back this way is going to be the same as the incident. Now the speed of the transmitted pulse will be greater than the speed of the incident pulse. So the wave that ends up in this medium is going to move faster than the one here. Okay? Now the wavelength of the transmitted pulse will be greater than the wavelength of the incident pulse. So because this is less dense, whatever this wavelength is, this one is going to be longer. So if this is the wavelength here, over here, it's going to be a bigger wavelength. Now the frequency of the transmitted pulse is going to be the same as the frequency. Now let's look at this second case then. The reflected pulse will be inverted. If you go from a less dense to a more dense, think of this as situation as like the fixed end that I talked about in the first page. So the reflected pulse will be inverted, okay? It will be inverted, all right? Less dense to more dense. Because this is more dense, it's gonna seem like this thing is fixed. And so this wave is gonna come this way. When it hits this, it's gonna get flipped upside down and it's gonna come back this way. The speed of the reflected pulse is the same as the incident pulse. So as fast as it's moving this way, fast as moving this, coming back. The speed of the transmitted pulse, okay? So here, it's moving at this speed, right? When it hits this this more dense here, it's gonna slow down. So the speed will be less than the speed of the incident pulse. The wavelength of the transmitted pulse will be less than the wave of the incident pulse, okay? And then here, the frequency of these will be the same.